Hey Math 3 welcome back. I'm going to be diving into task 4.10, starting with the warm-up, and then 4.11. This is my reminder to you guys to always make the absolute most of this task video. Pause it, rewind it, fast forward it, definitely change that playback speed to speed it up or slow it down so you get the most out of it. Okay, here is 4.10. We are starting with a new Ferris wheel. It tells us that it has a radius of 40 feet with a center at 50, and it rotates counterclockwise every 18 seconds, which means that if I find the angular speed or the frequency, I would say 2 pi, which is my full circle, divided by 18, which gives us pi over 9. So when we create our equation, I went ahead and did this for you. If you're still struggling with this and want some more practice, please ask in office hours. Our radius is 40, so when we set up that little triangle, we're going to end up with a sine, looking for the opposite side. So 40 sine are pi over 9t plus that 50, which reaches right to the center. Okay, so that's setting up the equation for this new Ferris wheel, but the next one is actually saying at what time is the rider 70 feet off the ground. So I want to think about this logically first. Here is our center of the wheel at 50. Here is our very top of the wheel, plus our 40 gets us up to 90. So 70 should be somewhere right in between. And if you notice, there are going to be two different places on our wheel that cross that 70 mark. So I could go with it like that, or I could actually use my equation for how it was meant to be. When I'm using my equation, let's block this off really quickly, I'm actually setting it equal to 70. I'm saying, well, this equation right here, 40 sine pi over 9t plus 50, has to equal 70. It has to equal 70. So let's go ahead and do that. I'm going to dive in and I'm just going to solve for it. I'm going to start by subtracting 50 from either side. That leaves me with 20 equals 40 sine pi over 9t. Divide both sides by 40. And I end up with 1/2 equals the sine of pi over 9t. Get that other 40 in there. Well, what do I do with that? That's actually asking the question, when is the sine equal to 1/2? So I can check out my unit circle. Again, let's kind of remind ourselves what exactly it's asking. It's asking for the inverse sine of 1/2, or again, where is the sine 1/2? Where is the sine 1/2? If you check out your unit circle, that's actually in two different places. If we kind of take this first path, that's at pi over 6, and I can multiply both sides by 9 over pi to get a time of 1.5 seconds. Pause the video, find the second angle. Find the second angle and the second time. Hopefully you found that that second angle was 5 pi over 6. So multiplying both sides by 9 over pi just to get t by itself, we find that the second time is 7.5. Let's go back to our diagram. This is 0 seconds. A full rotation is 18 seconds. So that means our half rotation here is 9 seconds. Does it make sense that this right here is 1.5 and this right here is 7.5? Yeah, I think that works out quite nicely. That matches up with what we see already. So let's ask a trickier question. Number 3 says, use your answer to write an equation to show when the rider is 70 feet above the ground forever, meaning we're going to rotate around and around and around and around. So I'm going to kind of just envision now we're not stopping. We're going around again. Well, that's just plus 18. Let's go around another time. Another plus 18. Let's go around another time. Another plus 18. Let's go around another time. And I can keep adding 18 forever and ever and ever and ever. 18 seconds later, I'm going to be right back here. 18 seconds later, I'm going to be right back here. How do we write that as an expression? Well, we can write it as 1.5 seconds plus 18 times n, where n is every rotation of the wheel. Well, we can do the same thing for the second one. 7.5 is also going to repeat every 18 seconds. So 7.5 plus 18 times n. Now let's check out question 4. Question 4 is saying if we used a sine function, let's revise it to be cosine. Let's revise it to be cosine. Well, if I'm thinking about the main difference between a sine and a cosine function, sine right here is going to start out with 0, right? There's no added height yet. Whereas cosine needs to start out at the max. As a cosine function, it needs to start out at the max. So what we're actually doing is doing a little quarter turn rotation here, or quarter turn pushing this forward. We're going to push it forward by pi over 2. Well, that's just a phase shift. And if you've explored those on Khan Academy, we know that phase shift gets added to our x value, or in this case, our t value. So the simple way we can change this is by rewriting it as cosine and using a phase shift.